Today we're going to talk about radicals and how do we simplify radicals. So you have probably seen a radical before. It is something with a square root symbol. So one thing we're going to talk about really quickly are the parts of the radical. So the number in front, just like with polynomials, this is called the coefficient. So a lot of the language is the same. So any number in front of the radical is a coefficient. The square root symbol, that is the actual radical. And then the number inside of it is called the radicand. So a little bit different of a word you might have not heard before, radicand. So coefficient, radical, radicand. So what we're going to learn to do today is how to simplify radicals. Before we can do any addition, subtraction, multiplication, you've got to learn how to get a radical in its simplest form. So we're going to break this in two parts. First, building the tree that helps us figure out how to simplify, and then what do we do with it? So what we're going to do is something called prime factorization. You have learned about factor trees before, which is what we're going to build, but we're going to do it specifically with prime numbers. Okay, so this method has us build a factor tree out of prime numbers specifically. So to refresh on prime numbers, they're numbers that are only divisible by itself in 1. So the first prime number we ever have is 2, then 3, 5, 7, 11, 13, 17, 19, and so on. It just keeps going. There are an infinite number of prime numbers. Really, we don't go past 11. Maybe we get a 13 every now and then. So this is usually what we're working with, these beginning numbers. So what we're going to do is we are going to break apart the number inside the radical, so the radicand, by pulling out the smallest prime number possible. And we're going to put it on the left side of our tree. And whatever is left over when we factor that out is going to go to the right. So I'm going to show you exactly what that means in our first example before we move on. So for example, we have the square root of 27. This is a large number that can be simplified. So what we're going to do is factor out, factor means to divide out the smallest prime number. So always start with 2. So I'm going to see if 27 is divisible by 2. I get a decimal, so no, it is not. So then I do 3. I pick the next smallest number. So I get the number 3. 3 is what can come out, and so I put that on the left like the direction said. Now, what is left over? The number 9. So 9 is going to go on the right. And then we're going to continue factoring out prime numbers until whatever we have left is also prime. So we broke apart 27 into 3 and 9. 9 is not prime. We can break this apart again. So we're going to, again, look to pull out the smallest prime number. Now, in your head, you may already know 2 cannot go into 9. 3 is a prime number that can come out. And when we take out a 3, again, if you need to check 9 divided by 3, we are left with 3. So our 9 broke into 3 times 3. The leftover number is prime, so that means we are done. And that's what we're going to do. We're going to do a couple examples of just breaking apart the tree. So this next one, 50. What is the smallest prime number that can go into it? Well, 50 is an even number, which means 2 can automatically go into it. So I pull the 2 out to the left, and my leftover is 25. So we broke the 50 into 2 times 25, right? Because that equals 50. We're just breaking it apart. Now, 25, we need to break apart. So 25 is not divisible by 2. It is not divisible by 3. So our next prime number is 5, and we see it does factor out evenly. 25, we take out a 5, and we are left with 5. 5 is prime, so we are done. Now, again, we're just practicing the tree right now. We'll learn what to do with this in a minute. So if you're like, okay, what's the point? We'll get to it, but first we just want to be able to practice the tree. So 32, that is divisible by 2. I get 16. 16 is not prime, so I need to keep going. So 16, let's see if that's divisible by 2. We always do the smallest one first, which is 2. It is, and I get an 8. 8 is divisible by 2, so we get a leftover of 4. 4 is not done. We are not at a prime number yet, so we have to break it apart one more time. 2 is prime, what we're left over with, and so we are done. So the 32 broke into 2 and 16. 16 broke into 2 and 8. 8 into 2 and 4, 4 into 2 and 2. And what you see is that we just have a list of all these prime numbers factored out of the number 32. All right, one more, and then I'm going to have you try one on your own. So 84, that is even. So the first number that we're going to take out is a 2. So 2 comes out, and we're left with 42. 42 is even, so we divide it by 2, and we get 21. Now, 21 is not even, which means the smallest prime number, 2, is not going to be able to go into it. So we try the next one. Remember, we always go in order from least to greatest. So does 3 go into 21? It does. And we're left with 7. Now, 7 is also prime, so always check with your list, which means we are done. I am done breaking this apart. So I am left with 2, 2, 3, and 7, and you should be left with just prime numbers. So I'm going to have you guys try a couple on your own. So go ahead and pause the video, try 28, and then play it. And you're going to go through doing 1, 2, 3, and 4. I'm going to do all of them as well, so you can check on the video. So try 1, then play it, then pause after you see if you got it right. Try 2, play it, try 3, play it, and so forth. So we're going to go all the way through 1 through 4. So pause it, try number 1. Okay, 28 breaks into 2 and 14. 14 is going to break into 2 and 7. 7 is prime, which means we are done, so it just broke into 2, 2, and 7. 8. 8 breaks into 2 and 4. 4 breaks into 2 and 2, so we are done. So again, make sure after you check this one, pause it and try the next one on your own. So pause it, try 3. All right, 45. 45, 2 cannot go into it. So the next number that we are going to try is 3. 3 does go into it 15 times. Now 15 is not prime, so we've got to break it apart. And we see that 3 and 5 go into it. Now 5 is prime, so we are done. So pause, try 4, and then play it on your own. All right, 48. This breaks into 2 and 24. 24, we get 2 and 12. 12, we get 2 and 6. 6 breaks into 2 and 3. So all of these broke apart until we were left with a prime number, and that's how we know we're done with our tree. Everything else we broke apart, and so it's no longer there. It doesn't exist, so we just have these trees of prime numbers. All right, so what do we do with these? So what we're going to do is first circle all the pairs of the same number. Remember, a pair means sets of 2s. So if you look at this first example, even though I have 3 3s, I can only circle in 2. So I have a pair of 3s, and then I have a 3 left over. Now, whatever number you circled, that value is going to go on the outside of the radical. Any prime number that is not in a couple, so this is 3, this is left out of my pair, that's going to go back inside. Okay, so the way I'm going to write this, my final answer is going to have a radical. The couples go out of the house, so when they come out, here's the trick though that a lot of people will mess up. We only count this as one item, 1 3. So when I pull it out, I'm only writing 1 3 on the outside, and that single goes back in. So we'll practice that again. So I have a pair of 5s. My couples go out. I have a single 2. The single is going to go inside. So before I write it here, though, we have one extra thing we need to pay attention to. If you look, there's already 2 on the outside. Remember, numbers don't disappear in math. That 2 is going to stay there. But now I'm going to write a 5 on the outside with it because couples go out, and the single 2, that is going to go back in the house. Now, if there are multiple numbers outside of the house, like we have in this example, you are going to multiply them together. So 5 times 2 is 10, so I get 10 square root of 2. The same rule is going to happen if there are numbers on the inside. If there's multiple numbers that go back in, you multiply those as well. So that's a little bit rarer, but we will see that in a second. So what about an example where there's all 2s like this? Again, you can only circle in pairs. So I have 2 pairs of 2s. This pair goes out, this pair goes out. This single guy is going to stay in. So when I write it, I have 2 sets of 2s that go out and 1 2 that stays in. Right, the single goes back in. So I have multiple things on the outside, 1 per group. So 2 times 2 is 4. 2 goes back in. Now, in this next example, we're going to see a pair of 2s that comes out with the 4, so 4 times 2. But if you look here, this is not a pair of the same number, but I do have more than one single. So the rules of math never change. If a number is single, it goes back inside. So inside the radical, we're going to have a 3 and a 7. Now remember, the rule is if you have more than one number in a space, you multiply them. So I have more than one number outside, so 4 times 2 is 8. And then I have more than one number inside, so that is going to be multiplied 3 times 7, 21. Now, if you look at these answers right here, what did we exactly do? Simplifying the radical is getting the smallest possible number on the inside. So if you look, we went from a 27 to a 3, a 50 to a 2, a 32 to a 2. So what we did is we pulled out all the perfect squares that we could, that we took out, and then we're left with the smallest version or the simplest form of the radical. So what I want you to do right now is practice circling your couples, bringing them out, singles go in. So do that for 1 through 4, exactly like we did before. Try number 1, play it. Try number 2, then play it. Try number 3, play it, and see how you did. So pause and do number 1. Okay, couples go out. So I only have 1 pair of 2s. So the 2 is going to go on the outside. 1 single, so 7 goes inside. All right, pause and try number 2. All right, couple goes out, and this is one of the reasons why I always draw an arrow, is to remind myself if I have something already out there. So I have a 2 on the outside times that -3 that's already out there, and then my single 2 goes back in. 2 times 3 is -6. 2 goes back in. Couples go out, so 2 times 3 is 6. So again, if you need to, make sure you write this out to show all your work. So 2 times 3 on the outside, that 5 goes back in. So I have 6 root 5. This one's probably the biggest one. I have a 2, another set of 2. So I have 2 2s that come out, and I already have a -3 out there. So I have -3 times 2 times 2, and then that 3 stays in. -3 times 2 is -6. -6 times 2 is -12. So -12 root 3. All right. Now we are going to put it all together. So if you flip over examples 5 through 8, we're going to do all together, and then I'm going to have you try 2 on your own, putting it all together. So remember, the first rule is prime numbers. We're trying to take out all the prime numbers. So I'm just going to write the list again up here so we have it on this side. So 24. The smallest prime number that can come out is a 2, and I am left with 12. 12, the smallest one that can come out is a 2. We're left with 6. 6, the smallest one that can come out is a 2, and we are left with 3. Now 3 is prime, so we are done. Now what we're going to do is look for couples. So a couple is a pair, and I have a pair of 2s here, and that 2 is going to come out. Now I already have a -3, so this becomes -3 times the 2. And then look at this. We have 2 singles, right? All singles go back in. And then if I have more than one thing in an area, I multiply. So -3 times 2, -6. 2 times 3, 6. All right, 320. So first of all, it's even, so 2 is going to come out. So 32 divided by 2 leaves me with 160. 160 divided by 2 leaves me with 80. 80 divided by 2 leaves me with 40. 40 divided by 2 leaves me with 20. 20 divided by 2 is 10. 10 divided by 2 is 5. So we have a whole list of 2s, and then our last number is prime. So remember, when we break it apart, that previous number disappears because it broke into the 2 things that were multiplied to make it. So cross all those out. All we should have that are still there are prime numbers. So I have a set of 2s, and another set of 2s, and then a single 5. Couples go out, so I have 1, 2, 3 of these. 2 times 2 times 2, square root of 5. Single goes back in. 2 times 2 is 4. 4 times 2 is 8, so I have 8 root 5, and that is my answer. All right, next one, 75. It is not even, so prime number 2 cannot come out, but I can take out a 3. So 3 goes in here 25 times. And again, just use your calculator for this. There's no problem with using your calculator, so if you need it, use it. 25, 2 cannot go into it, 3 cannot go into it, but 5 can. So this breaks into 5 and 5, with 5 being prime, so we're done. All the other numbers were broken apart. So I have a pair of 5s. That's going to come out. So -3 times 5, and then that single 3, that goes back in. So -3 and 5 is -15 root 3. All right, 96. This is even, so a 2 can come out. I have 2 and a 48. 2 comes out of here, and we have 24. 2 comes out, and we have 12, 2 and 6, 2 and 3. So remember, all of these big numbers canceled out, or we broke them apart, and so all we have are our prime numbers. I have a pair of 2s, and single 3s and 2s. So couples go out. Always remember to draw that arrow so you can reference, do I have anything out front? So we have that 4 out there, times a 2, times another 2, and then 2 and 3 go back inside. 4 times 2 is 8. 8 times 2 is 16. So we have a 16 root 6. Okay. So what I'm going to have you guys do is try 5 and 6 on your own. So go ahead and pause the video, do that now. Check with the video, and then we're going to save the rest as kind of our check for tomorrow to see how we do. We'll review a couple, and then I'll have you do some on your own tomorrow to see how we do. So try 5 and 6, pause the video, and then play it, see how you did. All right, 75. 2 cannot go into it. 3 cannot go, or 3 can go into it, sorry. 3 goes into it 25 times. And again, just use your calculator to check, go down the list. 25, 5 goes into it 5 times. So it breaks apart into 5 and 5. We're done because 5 is prime. Now we have a pair of 5s. 5 comes out with the 5 that is already there. And we are left with that single 3. Don't forget to look for your singles. That single 3 goes back in. 5 times 5 is 25. And then the single 3. 80. 80 is even. So automatically 2 comes out because that's the smallest prime number possible. And we're left with 40. 40 breaks into 2 and 20. 20 breaks into 2 and 10. 2 and 5. So remember the 80 went away, the 40, because all of these broke up, and we are left with 5 as our final prime number. Couples go out, so look for all your couples. So I have 2 sets of couples. Both of those come out with the 7 that was already there. So 7 times 2 times 2, and that 5 goes back in. So 7 times 2 is 14. 14 times another 2 is 28. So we have 28 root 5. Okay, so we're going to save the rest of these to work on in class to get started tomorrow.